morning, my everyone. Today I'm going to explain you about binomial distribution. Okay, let me start with binomial distribution. There's a relationship between Bernoulli and binomial distribution. So the same Bernoulli experiment, please listen, ma. Bernoulli experiment, if you repeat for n times, Bernoulli experiment, if you repeat for n times, it gives rise to binomial distribution. So Bernoulli experiment, which is repeated for n fixed number of times, it gives rise to binomial distribution. So binomial distribution is similar to that of Bernoulli, but Bernoulli you have to repeat for n times, where n is nothing but number of times you do an experiment. For example, taking tossing of a coin. So I'm doing a tossing of a coin for 2 times. So what is the experiment here? Number of trials, 2 trials. I'm doing an experiment for 2 times. So what are the outcomes you can expect? Either head or tail. Now in binomial experiment, n is the fixed number of trials. Okay, n is the fixed number of trials, and x will be the number of successes, p will be the probability of success, q will be the probability of failure. So I'll define the binomial distribution. So binomial distribution is a distribution. If we repeat Bernoulli for n number of times, it gives rise to binomial distribution. And it is defined as a random variable x. And which random variable it is? Binomial means it is a discrete binomial distribution. A discrete random variable x is said to follow binomial distribution if it has following probability mass function. So what is the probability mass function? Number of times you do an experiment, NCX. Out of n times you want x success. So NCX into p power x, q power n minus x. X will range from 0 to n times, where n is number of times you do an experiment and 0 otherwise. So what do you mean by 0 otherwise? So here x is nothing but in binomial experiment, we are doing an experiment for n number of times. In that n times, we are interested in calculating how many success you get. For example, if you take tossing of a coin 3 times, how many success you may get? I want getting a head. 3 times I am tossing a coin. Tossing a coin for 3 times. So what are the possible ways of outputs, ma? 3 times if I toss a coin, all the time it may show head. All the 3 coins may show head, head. That means how many success? 3 success. If I get 2 heads and 1 tail, what will happen? 2 success. Getting a success. Success is nothing but here head. Getting a success is head here. So if I get head, tail and tail. So how many success you get? 1 success. If I get all the tails, so now what is the range? What are the possible ways of getting success? It can be 0 success, 1 success, 2 success, 3 success. How many times I am doing an experiment? 3 times I am doing. So what are the possible chances for success? It can be 0 or 1 or 2 or 3. I am doing an experiment for 3 times. The success can be 0, 1, 2, 3. Similarly, if I do an experiment for n times, what are the success? 0, 1, 2, so on up to n success. Now, here out of n trials, we are finding out how many success we get. So we are selecting x success out of n. So NCX. And p is the probability of success. So p power x. And q is the probability of failure, which is nothing but q power n minus x. So what do you mean by this 0 otherwise? So this binomial distribution is defined only from 0 to n. If you get other than 0 to n, the corresponding probability will be 0. Only from 0 to n, it is NCX, p power x, q power n minus x. Other than this range, the probability mass function will be 0. Okay. Now, in this, we can say that X follows binomial distribution. Here, two parameters are there. What are those two parameters? N and P. We can write it as X follows binomial distribution with two parameters, N and P. N is called number of trials and P is called probability of success. And here, P comma Q, both are probabilities. P is probability of success, Q is probability of failure. Both are probabilities, they lie between 0 to 1. And this N is positive integer, number of times you do an experiment. And P is probability of success. So these are about your definition of your binomial distribution. NCX, P power X, Q power N minus X. And N and P are called as the parameters of binomial distribution. Now, going to the next topic. So, what are the situations, conditions under which we use this binomial distribution? So, the first condition is, the first conditions for existence of binomial distribution. The first condition is, the trial should be independent of each other. Trials should be independent of each other. What do you mean by independent? For example, I am taking tossing of a coin. So in tossing of a coin, first time I have tossed a coin. What are the outputs you can expect? Either head or tail. And when you do experiment for the second time, so what will be the output? First time you got head. So does it will affect the second outcome? So first time you got head. So second time will you get tail? No, it's not like that. So the outcome of the first trial will not be affecting the outcome of the second trial. They're completely independent of each other. And the second one is, each trial results in any of the two possible outcomes. That is success and failure. Any experiment which results in only two possible outcomes, success or failure. And the third condition is, the success P is constant for each trial. The success P is constant for each trial. Example, first time I have tossed a coin. I got head. What is the probability of head? Sample space, when you toss a coin, you will get head and tail. So what is the probability of head? 1 by 2. Second time I have tossed a coin. So what is the thing you are going to get? I got again head. What is the probability of head? It will be 1 by 2. 100th time I am doing the experiment. At 100th time experiment, again I got probability of head. What is probability of head? 1 by 2. That means probability of success remains fixed from trial to trial. It will not change. The probability of a trial will constant, will not be different from each other. It will be fixed. From trial to trial, probability of success remains constant. Now, for binomial distribution, the most important question, that is, you can go for mean and variance of binomial distribution. So how to calculate mean and variance? Just now we have done Bernoulli distribution, mean and variance. The similar way we can go for the binomial distribution, mean and variance. So first I'll explain about mean. So first mean. So how to calculate mean? So what is the formula for mean? Expectation of X. So binomial distribution is a discrete probability distribution. Discrete distribution means you have to start with the summation. What is the range of binomial distribution? We have studied the definition. X takes the values 0 to n. So X equal to 0 to n. X into P of X. What is P of X? Probability mass function of binomial distribution. X equal to 0 to n. X into, what is probability mass function of binomial distribution? NCX, P power X, Q power n minus X. Okay, now, so suppose that if I substitute X value over a 0, so what will happen? X is over 0, the entire probability will become 0. So the range will change from X equal to 1 to n. X into NCX, P power X, Q power n minus X. Now, Now, what is the formula for NCR combination? NCR formula. N factorial by R factorial into N minus R factorial. The similar way we expand this NCX. So, what is the expansion of NCX? N factorial by X factorial into N minus X factorial P power X into Q power N minus X. Now, summation is over, X equal to 1 to N. Now, I have here X. To cancel this X, I'll expand the X factorial. What is the expansion of X factorial? X into X minus 1, X minus 2, X minus 3, so on. So, what I do is here, X factorial expand up to X into X minus 1 factorial. So, I've expanded X up to 2 terms. In the similar way, N also I'll expand up to 2 terms. N into N minus 1 factorial. N minus X factorial will remain as it is. P power X into Q power N minus X. Summation X equal to 1 to N. So, the X term will be cancelled out. So, what are the terms left out? N into N minus 1 factorial by X minus 1 factorial, N minus X factorial, P power X into Q power N minus X. The next step is the summation symbol is over here. Summation is over, X equal to 1 to N. So, this N term is constant. This term I'll write outside the summation symbol. So, what will happen now? Summation. So, this constant term N, I'll write outside the summation symbol. So, the equation will become summation N minus 1 factorial by X minus 1 factorial into N minus X factorial to the power P power X into Q power N minus X. Now, using your NCR formula, what do you have here? N factorial, R factorial, N minus R factorial, you can write it as NCR. Similar manner, N minus 1 factorial by X minus 1 factorial into N minus X factorial, you can write it as N minus 1C X minus 1. If you expand this, N minus 1 factorial, X minus 1 factorial, N minus 1 minus of X minus 1. So, minus 1 plus 1 will be cancelled out. You will be left out with N minus X into P power X Q power N minus X. In order to write this in a particular combination, binomial expansion, so what I'll do is, I have here N minus 1. So, here also P power should be X minus 1. So, how to get P power X minus 1? The P should be in the denominator. So, directly I can't write P. So, what I'll do here? Multiply and divide with P. I'll write here multiply and divide with P. So, what will happen? N into summation X equal to 1 to N, N minus 1 C X minus 1, P power X Q power N minus X. So, multiply and divide with P. So, what will happen? P power X by P. A power M by A power N is A power M minus N. So, P power X by P will be P power X minus 1. But numerator P is not required, and which is a constant independent of X. So, this constant term I'll write outside the summation. So, N into P summation X equal to 1 to N, N minus 1C X minus 1. So, P power X by P will become P power X minus 1 Q power N minus X. Now, NP into, and this is if you substitute the values, you get your binomial expansion. We have a formula. If you have NCX, P power X, Q power N minus X, you can write this as P plus Q whole power N, your binomial expansion. P plus Q whole power N, that means X plus Y whole power N formula. So, observe this term with this. What do you have? What is the difference do you observe here? N minus 1C, X minus 1 and P power X minus 1. So, the same, both the terms are same. So, in place of P, you have only P. In place of Q, you have Q. whole to the power n, but in place of n what do you have? N minus 1. So np into what is p plus q? P is probability of success, q is probability of failure. So total probability will be 1. So 1 power n minus 1. Anything to the power 1 is 1. So the mean of binomial distribution is NP. If you observe, your Bernoulli distribution mean is P and binomial distribution is NP. Bernoulli we are repeating for n times we are getting binomial distribution. So the mean of binomial is n into P. So let us derive about the variance of binomial distribution. So variance. What is the formula for variance? Second moment minus first moment whole square. That is mu2 dash minus mu1 dash whole square in terms of moments. So expectation of x square minus mean. Just now we have derived mean. So what is mean of binomial distribution? NP. NP whole square. So which is nothing but expectation of x square minus n square into p square. Okay, let us consider this as equation 1. Now we'll calculate expectation of x square separately and we'll substitute over here. So consider expectation of x square. So you have a formula to write your x square. So this expectation of x square, you can write it as x into x minus 1 plus x. If you know that, you can write x square as x into x minus 1 plus x. If you simplify this, x square minus x plus x, you'll be getting with your x square. So in place of x square, I'm writing x into x minus 1 plus x. You have studied in the previous semester mathematical expectation. So using the addition theorem of mathematical expectation, expectation of first term plus expectation of second term, expectation of x, which is nothing but expectation of x into x minus 1 plus expectation of x. What is expectation of x? Binomial, that is mean of binomial distribution, which is nothing but NP. Now this one separately I'll calculate and I'll substitute here. So x into x minus 1. So summation, because binomial distribution is a discrete distribution, and what is the range of binomial distribution? 0 to n. And what is the term over here? X into x minus 1 into p of x. What is the probability mass function for binomial distribution? NCX, p power x, q power n minus x. And if you observe the range of your binomial 0 to n, if we substitute here 0, what will happen? Entire the probability will become 0. And if you substitute 1 minus 1, 0. Again the probability entire term will become 0. So the range will, x takes the range from 2 to n. Summation x equal to 2 to n, x into x minus 1. So what should I do? NCX, just same as your mean. We have expanded your NCR formula. So what is the formula for NCX? N factorial by x factorial into n minus x factorial. The remaining terms will remain as it is. Okay, now and here what will happen? Expectation of x into x minus 1, I'll write it as summation x into x minus 1. So what will happen to your n factorial x factorial into n minus x factorial? How many terms you have here? X into x minus 1. So I also have to expand x factorial as x into x minus 1 into x minus 2. So I'll write here as, so this expand, I'll expand x. So what will happen to the denominator term? X into x minus 1 into x minus 2 factor. I'm expanding 3 terms. So similarly, n also I can expand up to 3 terms. N into n minus 1 into n minus 2 factorial. And you have here n minus x factorial which remain as it is. n minus x factorial. P power x, q power n minus x. Summation x and x minus 1 will be cancelled out. So what is left out? X equal to 2 to n into n minus 1 into n minus 2 factorial, x minus 2 factorial, n minus x factorial, p power x, q power n minus x. So if you observe the derivation, everything is similar to your mean derivation. Now n and n minus 1 with respective to x, they are constant. So I'll write outside the summation. So what are the terms left out over here? N minus 2 factorial, x minus 2 factorial and n minus x factorial. Now you can use here NCR formula. P power x, q power n minus x. N into n minus 1 summation. So this entire term you can use in your NCR formula. You can write it as n minus 2c x minus 2. P power x into q power n minus x. And if you want to use this formula, you have your x minus 2. P power should also be x minus 2. So you want x minus 2 means in the denominator you should have p square. To get the denominator p square, I'll multiply and divide with p square. So multiply and divide with p square. So what will happen? N into n minus 1 summation n minus 2c x minus 2 p power x q power n minus x multiply and divide with p square. I want p power x minus 2. So denominator term is required. So numerator is a constant. I'll write outside. So n into n minus 1 p square summation n minus 2 c x minus 2. What will happen? P power x by p power 2, p power x minus 2, q power n minus x. So n into n minus 1 p square. So according to the formula, so what do you get, ma? P plus q whole power n minus 2. P plus q whole power n minus 2. What formula we are using here? NCX, p power x, q power n minus x, which is nothing but p plus q. Yeah, binomial expansion, x plus y whole power n. So in place of p you have p, in place of q also q, but in place of n you are getting n minus 2. So p plus q whole power n minus 2. So n into n minus 1 into p square, and p plus q is probability of success plus failure is 1. So 1 power n minus 2. Anything to the power 1, it is 1 only. So n into n minus 1 p square. So this is the derivation of your x into x minus 1. If you substitute over here, we get the value of your second moment. Once we get second moment, easily we can calculate our variance. Okay. So I'll substitute the value over in this equation, ma. So what will happen to the second moment? What is second moment? Expectation of x into x minus 1 plus np. So what will happen? You got n into n minus 1 p square plus np. Now we want to calculate our variance. So what is variance? Variance equal to expectation of x square minus n square p square. So what is expectation of x square? N into n minus 1 p square plus np minus n square p square. From here only the simplification part, mathematical part. N into n square p square minus n into p square plus np minus n square p square. Both the terms will be get cancelled out, and here we are taking the common term. It will be cancelled out. In both the terms we can take the common term np. If we take the common term np, 1 minus p. And what is 1 minus p? 1 minus success, which is nothing but failure. We know that total probability is 1. So q equal to 1 minus p. So the variance of binomial distribution is n into p into q. And today's class we have studied about the binomial distribution. And binomial distribution we have derived mean and variance. Mean is NP, variance is NPQ. And that's all for today, ma. Thank you.